And let us consider evaluating the integral of, okay, let us see, quantity 2x squared plus x plus 1 dx over the denominator x minus 1 quantity x squared plus 1. Okay, look at the integrand. 2x squared plus x plus 1 over x minus 1 x squared plus 1. It is rational in form, but of course the numerator is not the exact differential of the denominator. Hence, we have to decompose first the integrand into sum of partial fraction. And since the denominator consists of one linear factor and distinct linear factor rather and distinct quadratic factor, then we can have the rational function 2x squared plus x plus 1 over x minus 1 times the quantity x squared plus 1 be decomposed as sum of partial fractions a over x minus 1 for the linear factor, the distinct linear factor x minus 1. And since we have here x squared plus 1, okay, it is good that the denominator is already in the factored form, and please take note that x squared plus 1 is quadratic and it can't be factored anymore as linear factors. Okay, therefore, we will classify it under quadratic factor in the denominator. And it can be decomposed into sum of partial fractions. Now we have the constant a, so we can now use b. Okay, the denominator is the quadratic factor x plus 1. Okay, and we have to multiply b by the derivative of the quadratic factor x squared plus 1, which is equal to 2x. Then plus another constant c. So for the linear factor, distinct linear factor x minus 1, we have the partial fraction a over x minus 1. And for the quadratic factor x squared plus 1 in the denominator, okay, it corresponds to the partial fraction in the form b times 2x plus c over the quadratic factor. Okay, now please take note that we can also express this as sum of fractions a over x minus 1, then plus b times 2x over the quadratic factor x squared plus 1 plus the constant c over the quadratic factor x squared plus 1. And of course, our goal here is to determine the values of the constants a, b, and c. Okay, so let us do that. Find the values of a, b, and c. So we write here 2x squared plus x plus 1 over the denominator, which is already in the factored form. Okay, and we can express this as sum of integrals, sum of partial fractions rather, a over x minus 1 plus b times the quantity 2x over x squared plus 1 plus c over x squared plus 1. Okay, now to simplify the resulting equation, we can multiply both sides by the LCD. And of course, the LCD is x minus 1, x squared plus 1. Therefore, that will result to, on the left member, we will have 2x squared plus x plus 1. And on the right member, we need to multiply each term by the LCD. And that gives us a times x squared plus 1 plus b times 2x times x minus 1, and then plus c times the quantity x minus 1. Now, there is only one value of x that makes the denominator 0, and that is x is equal to 1. Now, we will consider the linear factor x minus 1, equate it to 0, and that will give us x is equal to 1. So, when x is equal to 1, now what will happen? We substitute the value x equals 1 in the equation. On the left member, we will have 2 times 1 square plus 1 plus 1. And this is equal to, okay, a times the quantity 1 square plus 1. And please take note that the remaining terms will be 0 since 1 minus 1 is 0. We have the factor x minus 1 in both terms, and if we will substitute x is equal to 1, that will result to 1 minus 1, which is equal to 0. So simplifying, we have 2 times 1 is 2 plus 1 plus 1, and that will give us 4 on the left member. And on the right member, we have a times 1 plus 1 is 2. Therefore, if we will solve for a, then a is equal to 4 divided by 2 is 2. So we have the value of a here, which is equal to 2. Unfortunately, there are no more values of x that makes the denominator 0. Okay, therefore, we have to use the other method, which is equating coefficients of x to the n. Now, if we are going to use the other method, equating coefficients of x to the n, then we might as well write this equation in the expanded form. So that will give us 2x squared plus x plus 1 is equal to a times the quantity x squared plus 1, okay, plus b times, we will multiply x minus 1 by 2x, so 2x squared minus 2x plus c times the quantity x minus 1. And we are going to equate coefficients of x to the n. Okay, so let's have it here. Equate coefficients of x raised to n. And we are going to start with the highest coefficient of x. And of course, if we will look at this form, the highest coefficient of, the highest power rather of x is x squared. Hence, we will equate coefficients of x squared first. Okay, so equating coefficients of x squared. Okay, look at the left member. We have the term 2x squared. Therefore, the numerical coefficient is 2 equals, on the right member, we have a times x squared. So ax squared, and the numerical coefficient of x squared is a. Then we have b times 2x squared. So that will give us 2bx squared. Numerical coefficient is 2b. And there are no more second degree terms. Okay, so that gives us the equation. We were able to generate an equation in terms of a and b, and 2 is equal to a plus 2b. But we have already the value of a, which is equal to 2. So substituting the value of a, which is equal to 2, will give us 2 is equal to 2 plus 2b. Okay, now if we will solve for 2b, of course, 2b will give us, transposing 2 to the other side, will give us 2 minus 2, and 2 minus 2 is 0. So this is equal to 0, therefore, b is equal to 0. Okay, a is equal to 2 and b is equal to 0. We still have another constant c. Okay, so to determine the value of c this time, we will equate coefficients of x squared. If we will equate the coefficients of x squared, Then look at the left member. We have an x term here. So we have x and numerical coefficient is 1. On the right member, we have b times negative 2x. So that will give us negative 2bx. Therefore, the numerical coefficient is negative 2b. Okay? And we have here c times x, which is equal to cx, and the numerical coefficient is c. And since a is equal to 2 and b is equal to 0, okay, then 1 is equal to negative 2 times 0 plus c. Therefore, if we will solve for c, then c is equal to 1. Okay? So a is 2, b is 0, and c is 1. Hence, we can express this as, okay, a is 2, so we will have 2 over the linear factor x minus 1, plus b is 0, so 0 times 2x over the quadratic factor x squared plus 1. Of course, since we have 0, 0 na itong term na to. And c is equal to 1, so that will give us 1 over the quadratic factor x squared plus 1. Okay, so going back to the integral, then the rational integrand, okay, can be written now as sum of partial fraction. Okay, we have integral of this one, okay. We have 2 over x minus 1 plus 1 over x squared plus 1 dx, which can be expressed as sum of integrals, integral of, okay, 2 times dx over x minus 1 plus the integral of the differential of x over x squared plus 1. Okay, hence, if we will evaluate the integral of dx over x minus 1, we can see that the numerator is the exact differential of the denominator. Therefore, the integral will lead to logarithm, and we can use the formula integral of du over u is equal to the natural logarithm of u plus c. Okay, hence we will have 2 times the natural logarithm of the denominator x minus 1. Now, what about the other integral? The integral is dx over x squared plus 1, integral rather of dx over x squared plus 1. And recall that we can evaluate this leading to arctan. We can actually express this, or this is exactly in the form integral of du over u squared plus a squared, where a squared is equal to 1, a is equal to 1. Of course, u squared is equal to x squared and u is equal to x. Therefore, the differential of u is equal to the differential of x. So the integral is exactly in the form integral of du over u squared plus a squared, which leads to arctan. Okay, so plus 1 over a, but a is equal to 1. So 1 over 1 is 1. Arctangent of u over a, u is x and a is equal to 1. So we simply write arctangent of x plus the constant of integration. Okay, therefore, this is the integral of 2x squared plus x plus 1 over x minus 1 x squared plus 1. It so happened that this is equal to 0, but if this is not equal to 0, then the integral of b times 2x dx over x squared plus 1 will also lead to logarithm. Okay, and it is, we are lucky here that the denominator is expressed in the factored form. Of course, just like what we did in part 1, if it is not in the factored form, then we have to factor completely the denominator of the given rational function, which is, of course, the integrand. Okay, let us have another example to illustrate part 2, where the denominator consists of quadratic factor. And this time, let us consider the integral of, okay, let me see. We have a quantity 3x squared minus or plus 4x minus 7 dx over the denominator, and the denominator is x squared plus x minus 10. Okay, so we can see that, okay, sorry, this should be x cubed. The denominator is x cubed plus x minus 10. And the integrand, which is in rational form, is a proper rational function. So we can decompose it into sum of partial fraction, but first we have to write the denominator in the factored form. Okay, hence we will have 3x squared plus 4x minus 7 over the denominator x cubed plus x minus 10. Okay, and we have to factor the denominator, and we can do synthetic division. Okay, now please take note that the denominator has a missing term x squared. So let us write it here. We have x cubed plus x minus 10. So if we will do synthetic division, then we will have 1, the numerical coefficient. Now 0 for x squared, then 1 for x, and then we have minus 10. Okay, and let us determine the roots so that we can write the factors. Okay, I don't think we can have plus or minus 1. If we will consider plus or minus 1, very unlikely that we will have plus 10 here to give us 0. Okay, kasi if we will have 1 times 1 is 1. So it will not be plus 10, whether it is plus 1 or minus 1. Okay, so let us try 2. Okay, bring down 1. 1 times 2 is 2. Okay, 0 plus 2 is 2. And 2 times 2 is 4. Okay, and that can give us positive 10. Okay, 1 plus 4 is 5. 5 times 2 is 10. So that will give us 0. So we have the root 2, and corresponding to the root 2 is the factor, the linear factor x minus 2. And of course, the other factor will be 1 degree less with numerical coefficients 1 to 5. Hence, we will have the other factor x squared plus 2x plus 5. If we have x squared plus 2x plus 5, of course, it is no longer factorable. No, you can actually test by using the discriminant b squared minus 4ac. If we will compute for the discriminant b squared minus 4ac, a is ito yung a, this is b, and this is c, right? Okay, therefore, we will have 2 square minus 4 times 1 times 5. And this will give us 4 minus 20, and 4 minus 20 is minus 16, which is less than 0. So b squared minus 4ac is less than 0. Okay, this is actually b squared minus 4ac, okay, which is less than 0. Therefore, the quadratic factor x squared plus 2x plus 5 is no longer factorable. Okay. Hence, to continue, then we will have this as 3x squared plus 4x minus 7. And in the denominator, we can now write the factored form x minus 2. And the other factor is quadratic, x squared plus 2x plus 5. Okay, and we have one linear factor corresponding to the linear factor is a over x minus 2, and corresponding to the quadratic factor x squared plus 2x plus 5, there corresponds sum of partial fraction. Okay, let us write x squared plus 2x plus 5. So we will have sum of partial fractions b times the quantity. Of course, we take the derivative of the quadratic factor, and the derivative is 2x plus 2. Again, we are doing this to eliminate correction. Okay? Then plus the constant c. And of course, we can also write this as a over x minus 2 plus b times the quantity 2x plus 2 over the quadratic factor x squared plus 2x plus 5. Okay, since we're done with factoring, let me erase this. So we need space. Okay, let me erase this one also. And we will have b times the quantity 2x plus 2 over the quadratic factor over c, plus rather c over the quadratic factor x squared plus 2x plus 5. Okay. So we have the rational function 3x squared plus 4x minus 7 over, okay, let us just have the factored form, x minus 2 times x squared plus 2x plus 5, okay, and this is equal to the sum of partial fractions a over x minus 2 plus b times the quantity 2x plus 2 over the quadratic factor x squared plus 2x plus 5, then plus c over the quadratic factor x squared plus 2x plus 5. And if we want to have the simplified form of this resulting equation, we have to multiply both sides of the equation by the LCD. And the LCD, of course, is x minus 2, x squared plus 2x plus 5. Okay, so multiplying the left member by the LCD will give us 3x squared plus 4x minus 7 is equal to, okay, multiply each term of the right member by the LCD. So a times the quantity x squared plus 2x plus 5. Okay, then plus b times the quantity 2x plus 2. Of course, we have to multiply this by x minus 2. Then plus c times the quantity x minus 2. Okay, let us write this also in the expanded form, since we will be using this in the second method of finding the constants a, b, and c, which is equating coefficients of x to the n. So we will have 3, okay, x squared plus 4x minus 7 is equal to a times quantity x squared plus 2x plus 5, okay, plus b times, okay. We multiply 2x plus 2 by x minus 2, and that gives us x squared. We have 2x times negative 2 is negative 4x plus 2x will give us minus 2x, right? So here, 2x times x is 2x squared, 2x times negative 2 is negative 4x plus 2x is negative 2x, and 2 times negative 2 is negative 4, plus c times the quantity x minus 2. Okay. Now, since there is a linear factor in the denominator, now we can use the value of x that makes the denominator 0. And we can have that by equating the linear factor x minus 2 to 0. So we use x is equal to 2 to determine a constant. Okay, so let us see. We will substitute x is equal to 2 in this equation in the factored form. So substituting x is equal to 2, then left member is 3 times 2 square plus 4 times 2 minus 7, right? And this is equal to, okay, a times the quantity 2 square plus 2 times 2 plus 5. Okay? Let us just make this bracket. And please take note that the last two term will be 0 since we have the factor x minus 2 in each term, since 2 minus 2 is 0. So let us just simplify this. 2 square, of course, is 4. 4 times 3 is 12 plus 8, 20. 20 minus 7 is 13 equals a times. Well, we have, of course, 2 square is 4. 2 times 2 is 4. So 8 plus 5 is 13. Therefore, if we will solve for a, then a is equal to 1. So we have value for a, which is equal to 1. Now we can now come up with an equation, no, by equating coefficients of x to the n. Okay, let me use other colors na lang para hindi mag-mix dito. Okay, so we will equate coefficients of x raised to n. And ang technique dito is to start with the highest power of x. And we are going to use the expanded form, this form. Okay, the second one. And we can equate coefficients of x squared. If we will equate coefficients of x squared, on the left member, we have 3x squared. Therefore, the numerical coefficient is 3 equals, on the right member, we have a times x squared. Therefore, the numerical coefficient is a. And on the second term, we have b times 2x squared or 2bx squared. Hence, the numerical coefficient is 2b and nothing else. But since a is equal to 1, then we will have 3 is equal to 1 plus 2b. Okay, excuse me. So 3 is equal to 1 plus 2b. And If we will transpose 1 to the other side of the equation, that will give us 2b is equal to 3 minus 1 will give us 2. Therefore, b is 1. We have a is equal to 1 and b is equal to 1. But there is another constant c. So this time, we can equate coefficients of x. And if we will equate coefficients of x, on the left member, we have 4x. Therefore, the numerical coefficient is 4 equals, we have a times x. Numerical coefficient is a. We're getting the numerical coefficient of x. Then b times negative 2x, therefore that gives us negative 2bx. Numerical coefficient is negative 2b. And we have c times x, numerical coefficient is c. Okay. Now, a is equal to 1 and b is equal to 1. Therefore, the equation becomes 4 is equal to 1 minus 2 times 1 plus c. Excuse me. Hence, what will happen? We will have 4 is equal to 1 minus 2 plus c. Okay, and if we will solve for c, then c is equal to 4. 1 minus 2 is negative 1, right? And if we will transpose negative, okay, tama ba? We have wait. We have 2x here, sorry. We have 2 times a, okay, here. A times 2x will give us 2ax. So this must be, sorry for that, this must be 2a. Tama na? And we have b times negative 2x, so we will have negative 2b. Okay, hence, let me repeat this. Sorry, okay, so we have 4 is equal to 2, a is equal to 1, so 2 times 1, minus 2 times b is also 1 plus c. Okay, which will give us 4 is equal to 2 minus 2 plus c. But 2 minus 2 is 0, therefore c is equal to 4. Okay, hence, we have a is equal to 1, b is equal to 1, and c is equal to 4. This time, okay, hindi na nag-0 yung b. Yung sa first example, we got b is equal to 0. So we are going to replace a, b, and c by 1, 1, and 4 respectively. Okay, so we will replace this by 1, b is equal to 1, and c is equal to 4. Okay, let us just have it in the integral. Hence, the integral can be resolved, no, as sum of partial fractions. No, a is equal to 1, so we will have, let us just write this as dx over x minus 2 and express it as sum of integrals. Then plus b is also 1, so we will have integral of quantity 2x plus 2 times the differential of x over the quadratic factor x squared plus 2x plus 5. And c is equal to 4, so plus 4 times the integral of the differential of x over x squared plus 2x plus 5. Okay, now look at the first two integrals. Okay, the numerator becomes what? Exactly equal to the differential of the denominator. dx is the differential of x minus 2. Okay, quantity 2x plus 2 dx is the differential of x squared plus 2x plus 5. Therefore, both integrals will lead to natural logarithm, right? Okay, hence, I will just move further left. The integral of dx over x minus 2 is natural logarithm of x minus 2. Okay, then plus the integral of 2x plus 2 dx over x squared plus 2x plus 5 also leads to the natural logarithm of the denominator x squared plus 2x plus 5. Okay, and the last one is 4 times the integral of x squared plus 2x plus 5. Of course, this will lead to arctan. Now, we can have a perfect square trinomial, x squared plus 2x plus 1. So, meaning we can write the integral as, okay, we have dx over x squared plus 2x. To make this a perfect square, we have to add 1. Where do we get 1? Okay, we can express 5 as positive 1 plus 4, or we can add and subtract negative 1. Okay, so we can group this. We have a perfect square trinomial. Okay, so natural logarithm of x minus 2 plus the natural logarithm of x squared plus 2x plus 5 plus 4 times the integral of the differential of x over, okay, we can factor x squared plus 2x plus 1 as two identical binomial x plus 1 squared plus 4. And note that the integral leads to arctan. And it leads to arctan where a squared, okay, where we will let a square is equal to 4 and a is equal to 2. Of course, we will let u square is equal to the quantity x plus 1 raised to the second power, and getting the square root of both sides gives us u is equal to x plus 1. And getting the differential of both sides, we have du is equal to dx. And look at the integral. Integral of dx over x plus 1 squared plus 4. Exactly in the form integral of du over u squared plus 4, which leads to arctan, okay, 1 over a arctan of u over a plus c. Therefore, we have a natural logarithm of the absolute value of x minus 2 plus the natural logarithm of the absolute value of x squared plus 2x plus 5, okay, then plus 4 times, okay, a is 2, so we will have 1 over a, or 1 half, arctangent of u over a. U is x plus 1 over a is equal to 2, plus the constant of integration. And we can cancel 4 and 2, no? Which will give us, meaning we can divide this by 2, which gives us 1. We can divide 4 by 2, which gives us 2. Hence, the integral is equal to the natural logarithm of the absolute value of x minus 2 plus the natural logarithm of the absolute value of x squared plus 2x plus 5, okay, then plus 2, okay, 4 times 1 half is 2, arctangent of quantity x plus 1 over 2 plus the constant of integration. And this is the integral of 3x squared plus 4x minus 70x over x cubed plus x minus 10. Okay, so this will end module 1.